So the first one we're going to talk about are discrete functions. Then we're going to talk about continuous, and then you'll be able to finish your study guide. Is everyone ready? So discrete functions. Discrete means one thing after another, and it's counting things. They're not connected, and your graph looks like distinct dots. It's a set amount each time. So your graph, instead of being a connected line, like most of our graphs have been, it'll be dots that form a pattern but aren't connected. Like that. Sam? What are we? Now that we're done with counting that. Alright, so let's open this and let's graph some discrete functions. So you have two kinds. You have kinds that you're going to plug in, and it'll say graph the discrete function where you just plug in the point. So all you have to do is you have to plug in x to get y. So let's make a t-table. And it tells us to plug in -1, 0, 1, 2, 3, correct? Now it gives us the function of y equals 2x minus 1. So all of your x values you're going to plug in where x is. So what's 2 times -1? And what's -2 minus 1?
-3.
Fantastic. Does everybody see where we got -3 from? Does anybody not see? Okay, let's plug in 0. What's 2 times 0? And what's 0 minus 1? Awesome. Alright, let's plug in 1. What's 2 times 1? And what's 2 minus 1? Awesome. Let's plug in 2. What's 2 times 2? 4 minus 1 is? And last one, let's plug in 3. What's 2 times 3? And 6 minus 1? Dun, 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 dun. That's how you use a t-table. Isn't it magic? So now you just plot your points. So -1, -3. You go left 1, down 1, 2, 3. 0, -1. You just go down 1. And remember, always start from the origin. 1, 1. You go right 1, up 1. 2, 3. You go right 2, up 1, 2, 3. And 3, 5. You go right 1, 2, 3, up 1, 2, 3, 4, 5. Now, since it's discrete, are we going to connect those dots? No. Fantastic. Any questions? Easy peasy? That's all you do. Isn't it lovely? Okay, let's look at our second one. This time, our function is y equals -x plus 4, and we're plugging in -2, -1, 0, 1, 2. Now, if it's a negative, what is that going to turn the number? Positive. Fantastic. So if I plug in -2, that turns it to +2. And what's 2 plus 4? Does everybody see where we got 6 from? Are you alive out there? Some people who are not part of the class are alive out there. All right. If you plug in -1, a -1 would be +1. And 1 plus 4 is? If you plug in 0, what's 0 plus 4? If you plug in +1, what's going to happen with that? It'll be a negative. Good. And what's a -1 plus 4? 3. If you plug in 2, what's going to happen to that? It'll be negative. And what's a -2 plus 4? 2. All right, graph this. I'm not Miss Jenkins.
Oh no, God.
It's okay though. We both have brown hair. Yeah. Yeah. No, those aren't parallel though. They'll eventually cross. those two lines that she has, those transversals aren't parallel. Do you see how if they keep going up top, they're going to cross eventually? Yeah. I know. Does your graph look like this? -2, 1, 2, 3, 4, 5, 6. -1, 5, 0, 4, 1, 3, 2, 2. Does yours look like that? Did you connect your dots? Why do we not connect our dots? Because it's a discrete function. Fantastic. Take a point. Now, the bottom we're going to identify why it is a discrete function. And then that's going to help us differentiate between discrete and continuous. So let's look at these two situations. First, it gives us the number of movie tickets we buy, right? And then it gives us the cost in dollars. Now, why would this be a discrete function? Why would we not connect the dots when we graph this? Grant?
Maybe I had something.
Okay, Maddie?
Maybe it doesn't keep going.
Kind of. You're on the right track. Think about what you're purchasing. And think about what the graph would mean if we connect it. So, for example, what I mean by that is on this graph, if I don't do this, just watch. If I connected these dots right here, right? That would mean that we would plug in -0.5 and get this point. That would mean that we plug in -1.5 and get this point. We would plug in 0.5 and get this point, right? So those are all dots connected. But why would we not connect this graph? Why would it be discrete?
Because we connected it, it's moving continuously,
Mhm.
so like you'd be continuously spending money.
Mm-hmm.
So
Kind of. You're getting there. I like where you're headed with that, and I like that where Maddie was headed that y'all were saying it would keep going continuously and forever, and you can't do that. But think about what we're purchasing. If I buy one ticket, how much am I spending? And if I buy 2 tickets, then I'm spending 17, right? And if I buy 3, I'm spending $25.50. Why would we not connect the dots? I kind of hinted at it when I told you that if we plugged in a 0.5 up here, that would mean that point. Cameron? You can't buy half a ticket. Yes, take a point. So you cannot purchase half a ticket. You cannot purchase half a ticket. So that means that you can't connect the dots because then you would be able to purchase half a ticket. Does that make sense? All right, what about the next one? Points during a game of laser tag. Do any of you play laser tag? I've never played laser tag, so I don't know what
We
that
have Key Club members and Diamond Dogs to the gym for pictures. Key Club and Diamond Dogs for pictures.
baseball people. Okay, so in laser tag, can you hit half of a target?
no.
You either hit the target or you don't, right? So when you graph this, why would you not connect the dots? Because you can't hit half a target. Yep. You can't hit half a target. Now, what about the amount of nachos you sell at a game versus the money you make? Would that be discrete or continuous? Can you sell a half thing of nachos? So what would that be? Discrete. If you purchase the number of shirts you purchase versus the money you spend, well, in relation to the money you spend, would that be discrete or continuous? Discrete, because you can't purchase half a shirt, though some shirts look like half shirts. Not calling them names out.
I have 2 half shirts combined.
Over there.
Hey now.
You have 2 half shirts combined?
Yes.
You made those?
No, my brother did.
Well, you didn't go buy those, did you?
I did.
You bought it from your brother?
Yes.
Oh, okay. Does anybody? Why did you purchase half a shirt, half a suit? Why?
Because they look cool.
Okay.
Besides, I was 7 at the time.
Oh, okay.
Me alone.
That doesn't make my picture better.
All right. So now, does anybody have any questions on discrete? Fantastic. Let's look at continuous. Also, did you notice that when we listed the domain, they were set numbers? That's very important. The range would also be set numbers. It would not be all the numbers between 6 and 2. It would be set numbers. All right. Continuous functions. A continuous function has a graph that is connected. So instead of distinct dots, it would be a line. Yes, the pass is in the middle drawer of my desk. Are you done with your rough draft? Okay, you're not going to the library. All right, open this Flappy. All right, so this says, my shoe just came off. I don't. All right, so this says graph the function y equals 2x minus 1 with a domain of x is greater than or equal to 0. So what numbers can we plug in for the domain this time? 0, 1, 2, 3, and 4. Who said that? Take a point, whoever me is. Thank you, Jackson. Does everybody see why we can plug in 0, 1, 2, 3, 4? Now, if it said that x was greater than 0, could we plug in 0? No. All right, plug those in. Do it without me. Find the range.
So I did my first try. I just don't do that.
That's not good. It's due today.
Can I send you a picture
I would get someone at your house to take a picture of it and send it to you now. No one's ever there.
after? So what do I like redo it?
You can send it to me. It's okay.
I did do it.
All right, what'd you get when you plugged in 0?
-1.
-1. Take a point if you said -1. What did you get when you plugged in 1?
1.
1. What did you get when you plugged in 2? When you plugged in 3? When you plugged in 4? Look at us go.
No.
All right, let's humana. Let's graph it.
Speak English.
So 0, -1, 1, 1, 2, 1, 2, 3, 3, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7. All right, then, now, normally we would connect and go both ways, correct? But it says that our domain is greater than or equal to 0. So can we go past 0 on the x-axis? No. So we can only connect this way and go on forever. Now, what's the range? What's our y values? Is it only those numbers? And we connected, right? So what number y is greater than or equal to what number? What's the smallest y value? -1. Yes, no, maybe so. Okay, do the same thing for the second one. Completely without me this time. Did y'all get those X and Y values? Fantastic. If you got it right, give your team a point. If everybody got it right, give your team 2 points. Oh, Blair. Ignore that dot. I don't know what happened at all or why I did that. Okay. Now, can we connect the dot and go left any? I mean, extend the dots rather than go left. No, because x has to be greater than or equal to 1. But we can extend and go this way, right? So what is our range this time? What?
3, 2, 3, 2, 1,
No.
2.
Well, yes, but it's also all these points in between. So when it's continuous, your range is going to look like this. When it's discrete, you list the exact points. So on a continuous function like this is, what is our range? Less than or equal to 3. Good. Take a point. All right. Any questions? Can we look at these situations and then go over our study guide? All right. Explain why this is continuous. Temperature of a fish tank during an experiment. Why would that be
Continuous.
But it's a fish tank, right? Okay. Does the time of, but it's not time of day, right? It's just time and hours. So I like where you were headed because you know that time of day affects temperature. We know that as like human beings that go outside.
It feels good outside.
Thank you for digressing. But at a half hour, can we measure the temperature? At a quarter of an hour, can we measure the temperature? At 1.5 hours, can we measure the temperature? So time is continuous, right? It doesn't ever stop. It's not just little blips. So time is continuous. And you can measure the water at any time. Alright, so what about the next one? Height of a rocket after a launch. Yes. I'll help you in just a minute. Yep. Y'all should have behaved.
Who didn't behave?
She really should.
Don't lie.
Teachers at this time, may I please have Skills USA TV film?
Alright, so why would height of a rocket after launch be continuous?
Skills USA TV film in
Pardon?
the gym. Thank you.
You can always get higher. And you can measure it at any point, right? Because it's time versus height. And time is continuous. So time is continuous. That's all you have to say. Time is continuous, and you can measure the height at any point. Alright, so do you want time to work on your study guide, or do you want to go over the parts of your study guide that you did last night? Go over it? Okay. And then you should still have time to finish it. It shouldn't take us that long. Alright, so tomorrow we're going to do a review activity to help us prepare for the test. Hopefully it'll be fun. If not, pretend. Alright, so let's look at number 1. It says, which relation is a function? Which one did you pick for it being a function? Are you saying B as in boy or D as in dog? Boy, yes. D as in boy, or bravo. Fantastic. Because none of the x values repeat. Alright, what about number 2? A is an apple. And why are those functions? X doesn't repeat. Take a point. Also change this to page 26. Okay, let's look at the back. Number 3. Which one is a function? C is in potato. I will agree with that because all the others you can draw a vertical line through it and hit 2 points, right? Yay! What about B? A? Why would A be a function and not B? Because of the dot. Take a point, Benjamin. Fantastic. Alright. Potatoes. Number 5. Which relation is a function? Oh, okay, I was just looking. Y'all breathe. Thank you. I'm so sorry. Alright. So, number 6 says, write the ordered pairs represented by the newspaper subscription table. Right? So, to write it as a set of ordered pairs, you would say 1, 15.25, and then 2, 30.50, and 3, 45.75, and 4, 61, 5, 76.25. Do we agree or disagree? And then we would graph it. Now, would this be a discrete or continuous graph? It would be a discrete. Why would it be a discrete? You can't buy half a newspaper, so please unconnect your dots if you connected them. This is a discrete graph. Can you plot that without me? Like, we can do that, right? Hopefully. Are we ready for number 8? Did y'all do the back?
Yes.
Okay, good. Alright, identify the independent and dependent variables in the newspaper subscription table. So what's independent? The months, yes. And what's the dependent? The cost, the money. Alright, and did you figure out how much it's going to cost for 1 year? What'd you get? 100 what? Do we agree or disagree with $183? Fantastic. Alright, express, oh, Blair.
Speak English.
I'm trying. Express each relation as a graph and a mapping. So I'm going to map it. I'm going to graph it because I don't have to. Haha. Sorry. Alright, so it's 2 and 3. And then -5, 1, 3, 4, correct? And 2 is matched with -5 and 4. And 3 is matched with 1 and 3. So that's what your mapping should look like, and then you just plot those points. Sorry that it's baby tiny. And it says determine the domain and range. So your domain would be your x values. And remember, you don't repeat them. So it'd be 2, 3, And then your range would be -5, 1, 3, 4. Okay, what's your domain of number 11? Take a point. And what's your range of number 11? Look at that. They're the same thing. Hot dog. Alright. Number 12. Describe what is happening in the graph. So this is the number of questions that they answer. And then this is time. So what's happening from here to here? They are steadily answering questions. And yours doesn't have to be exactly like mine. And then what do? Then they take a break. After they take that break, are they answering questions faster than they were before? I think so. Then they answer questions. Okay, Blair, that's not really how you spell questions. Faster, and then they take a longer break, right? And take a longer break. And what do they do at the end? They keep answering questions. Then they finish the test. That's what we'll say. Can we please put those on silent? It's crazy. Well, thank you for letting me. All right. Any questions on that? Could you do that on your own? Tomorrow you're going to have I'm going to give you some graphs that you're going to have to describe, and then I'm going to give you scenarios that you're going to have to graph. And it's going to be awesome. Number 13. The graph shows the number of home runs hit by Andrew Jones of the Atlanta Braves. Express the relation as a set of ordered pairs, then describe the domain and range. So, in the year 2002, how many home runs did Homeboy hit? 35. So 2002, 35. And then what about in 2003? 2004? 2005? 51. He went crazy that year. 2006. And 2007. He did not do so hot that year. And then describe the domain and range. So it's not telling you to label the points, it's asking you to describe it. So what's the domain? The years from when? And what's the range? Number of home runs he hit each year. Bless you. Okay, can you keep working without me now? Yay, go team. Anybody have any questions? Speak now, forever hold your peace.